The fourth option available in the Add Trendline window is the Power option. If we go back to the data we've been using, GNP and U5Mort, and we create a chart based on that data, an XY scatter chart, and finish, we get again the familiar data that we have been working with. If I right-click the data series and go to Add Trendline and select the Power model, then in Options select Display Equation on the chart and Display R² on the chart, I get this result. I'm accounting for 68% of the variance, and the equation given is 7475.5 x to the minus 0.7063. Okay, where does this equation come from? It is the best fitting line that we have seen for this curve data so far, but it is exactly the same result in terms of R² that we would get by converting GNP and U5Mort both to their log values. So let's do that and see if we can replicate this equation from that regression analysis. To begin with, I'm going to move the chart out of the way, and I'm going to put here GNP log and U5Mort log, and I will say that this is equal to the log. This is again going to be base 10 of the GNP for Niger, and I'll drag that to the right, so now I have the log of the under 5 mortality for Niger as well. Then I will click this down, and now I'll go to Tools, Data Analysis. I'm going to select Regression, and as you can see, the under 5 mortality has already been selected as the Y input range. GNP logged has already been selected as the X input range. We have labels. The output range is going to be G2, which is right here. When I say OK, I get this result. We've seen this result before. It was the same result that we got for the log of under 5 mortality regressed on the log of GNP in a previous video. And the intercept and the coefficient are exactly the same as that analysis. And if we look here at 0.68 for the R², that is what we get for the R² in the Power model. Now, the last time we looked at this set of data, we predicted the value of the log of under 5 mortality using a simple linear predictor with the value of GNP logged being multiplied times the minus 0.706 and adding the intercept value of 3.87. This time we're going to predict the value of under 5 mortality, and we're going to do it with these same coefficients, but we're going to use them in a slightly different way. To do that, I'm going to insert a column here, and this will be U5Mort predicted, hat P in this case, and I'm going to use these coefficients, but I'm going to treat them as if they were components of logarithms. If we look at the intercept and we say we're going to raise 10 to the power of the intercept, we get 7475, which looks very much like this 7475. So the constant in our new model will be equal to 10 raised to the power of the intercept. And I'll fix that with an F4. Now, because the intercept was stated in terms of logs, in order to transform it back to natural numbers, rather than adding the intercept, we're going to multiply the intercept. And we're going to multiply it times GNP, but not GNP alone. We're going to use GNP and raise it to the power of the coefficient for the log of GNP. And again, I'll fix that with an F4. Now the equation we have here is essentially 7475 times x raised to the power of the log. When we hit enter, we get 143.31. If we look at the equation here, this is the value of 10 raised to the coefficient on the intercept times GNP raised to the intercept on the log. That's exactly the equation that I have used to produce this result. Now I'm going to double left click this all the way down, and I have predicted values for each of the countries. Since this is under 5 mortality, stating in dollar terms is meaningless, so I will format it as a number. When I say OK, I now have the predicted values. Now let's look at the chart again, and this time let's drag the blue box to the predicted values of under 5 mortality, and you will see that we now have the pink dots that represent the predicted values for each country, and those pink dots follow exactly the line generated by the power model. In essence, the power model is simply the result of regressing the log of the dependent variable on the log of the predictor variable or variables.